In this video, I'm gonna go over these two examples from complex number. Like first one is they said prove that the sum of these four imaginary number is equal to 0, and then the product of these two complex number is equal to 16. So this problem we can solve it using two different methods. I'm gonna do both of them. So let's work on the first method first. So in the first method, what we're gonna do, let's write down left hand side here first of all. So left hand side is equal to iota 104 plus iota raised to power 109 plus iota raised to power 114 plus iota raised to power 119. So what I'm gonna do is I'm gonna change all these imaginary numbers in terms of iota raised to power 104, and then we can factor it out and simplify it. Okay, so iota raised to power 104 plus iota raised to power 109 can be written as iota raised to power 104 into iota raised to power 5. So I'm using the exponent property here. Okay, so you can add the power, same base, you add the power, you get 109. And here you got iota raised to power 104 into iota raised to power 10 plus iota raised to power 104 and iota raised to power 15. So now you see each term has iota raised to power 104 as a common factor. So I'm gonna take that out. So that gives me iota raised to power 104 into here iota raised to power 5, iota raised to power 10, and iota raised to power 15. Now I'm gonna use that iota raised to power 4 is equal to 1. You know why? Because iota square into iota square gives me -1 times -1, which is equal to 1. So I'm gonna write all these imaginary number in terms of iota raised to power 4. Okay, so iota raised to power 104, and this can be written as iota raised to power 4 into iota, and this one can be written as iota raised to power 4, iota raised to power 4, iota square. And then we got, what did I miss here? Oh, I missed 1. So 1 plus, here you go. And iota raised to power 15 can be written as 4 times 4 and iota raised to power 3. And this is basically iota raised to power 104 into 1, as iota raised to power 4 is equal to 1. So 1 times iota gives me iota, and here I left with the 1 times iota square, and here I left with the 1 times 1 times 1 iota cube, and 1 plus iota, and iota square is -1. So instead of iota square I can write -1, and iota cube is negative iota. Okay, so we're gonna cancel these out. This gives me iota raised to power 104 times 0, which is actually 0. Alright, and that is our right hand side. So hence the proof. And there is another method to solve this problem too. Let's do that way. So I'm gonna use the property, it says if iota raised to power n and n is greater than 4, then if we divide n by 4, let's say we got remainder r, then iota raised to power n is equal to iota raised to power r. Okay, let's use that method too. So let's write left hand side, which is iota raised to power 104 plus iota raised to power 109, iota raised to power 114, and iota raised to power 119. Okay, let me make some. So gonna use the method n is greater than 4, so divide this by 4. So this gives me 104 divided by 4 gives me 4 times 2 is 8, 4 times 6 24. So remainder in this case is 0. So I raised to power 104 can be written as I raised to power remainder, which is 0. Now let's do next one. So I raised to power 109. So 109 divided by 4. 4 times 2 is 8. 10 minus 8 is 2. Bring down 9. 4 times 7 is 28. Remainder is 1. So that means this next term is going to be I raised to power this remainder, which is 1. Let's do 114. 114 divided by 4. 4 times 2 is 8. Left with 3. Bring down 4. 4 times 9. No, 4 times 8. 32. So remainder is 2. So we're left with iota raised to power 2. How about 119? So divided by 4. 39. 4 times 9 is 36. Remainder is 3. So can be written as I raised to power 3. And anything raised to power 0 is a 1 plus iota, and iota square is a negative 1, and iota cube is a negative iota. See, 1 will cancel this 1, iota will cancel this iota, left with 0. So left hand side is equal to right hand side. Hence the proof. So there is like 2 different ways to solve the same problem. There might be more. So use the method whatever you like the most. But you see a lot of things happening here. You find out I raised to power 4 is 1. You can factor them out. And here you are using this method. That's where it says if I raised to power n and n is greater than 4, then divide this n by 4 gives you a remainder. Whatever remainder is that, then this I raised to power n is equal to I raised to power that remainder. Okay, let's go over second example. This one says the product of these two complex number is equal to 16. So I'm gonna use my left hand side here is equal to 1 plus iota 4 times 1 plus 1 over iota 4. So what I'm gonna do over here, I'm gonna write it as 1 plus iota square and then whole square. That way I can solve this and then square it. Same thing here, but before that I need to find a common denominator. So this is going to be iota plus 1 square and whole square. Okay, so this gives me now, so I'm gonna use the equality here, 1a plus b square, which is a plus b square is a square plus 2ab plus b square. All right, so let's use that here. So this gives me 1 square plus iota square, 1 square plus 2 times 1 times iota plus iota square, okay, whole square. So that's the equality I'm using there. So same thing here. So we got iota square plus 2 times iota times 1 plus 1 square over this square of this iota in the denominator and complete square here. So 1 square is 1, 2 iota, and iota square is a negative 1. And same thing here, iota square is a negative 1 plus 2 iota plus 1 over iota square is a negative 1 whole square there. So this 1 will cancel out this 1. This gives me square of 2 iota, which is 2 square is 4 times iota square. Same thing here, 2 square is 4 times iota square, and negative 1 square is positive 1. Okay, and this is a multiplication, not addition, multiplication. Okay, so this gives me 4 times iota square, which is a negative 1. 4 times iota square is another negative 1. So 4 times 4 is 16, and negative 1 times negative 1 gives you positive 1, gives you 16, which is our right hand side. That's the proof. Alright, thanks for watching the video, guys. Please practice more examples, and that way you will be good to go. I'm gonna make more videos on few more examples. If you like me to make a video on any particular topic, please comment on the video, and I'll try to make a video on that topic too. Okay, thanks for watching the video, and please do subscribe to the channel, and that way you won't miss any video I post. You can watch it immediately. Thank you. Have a good day.